Hello friends, today we are going to start chapter 4, that is pair of straight lines. So while discussing the points for this pair of straight lines, we discuss all the points that we studied in class 11 and in class 10 also. We discuss some points and formula first, then we start our actual portion, that is pair of straight line. So any point on x-axis has y coordinate 0. That means when we consider point on x-axis, we have to take its y coordinate as 0. See this first diagram. In this point we consider here, its coordinate we write in the form of a0. Any point on y-axis has x coordinate 0. In same way, if we consider a point on y-axis, then on y-axis we have to consider its x coordinate is 0 always. Third point, all the points on a line parallel to x-axis has same y coordinates. That means when we consider a line parallel to x-axis, see this second diagram, and we consider here line L. When this line L parallel to this x-axis, then when we consider point on this line, in that time we have to consider y coordinate is same. Fourth point, all the points on line parallel to y-axis has same x coordinate. That means when we consider a line parallel to this y-axis, that we denote here by capital M, when we consider point on this line M which is parallel to this y-axis, then its x coordinate is same. Distance of any point from x-axis is equal to the y coordinate of that point. Means when we consider a point, its distance from x-axis is always equal to the y coordinate of that point. Distance of any point from y-axis is equal to the x coordinate of that point. Now second topic is locus of a point. A locus is a set of points in plane which satisfy some given geometrical condition or conditions. A locus is also termed as a geometrical figure. For example, here we take one example. It is the set of those P such that P is a point in a plane and P satisfies given geometrical condition. Here P is the representative of all points in L. L is called the locus of point P. Locus is a set of points. Now the next definition is line. A line is the locus of a point such that if any two points on this locus are joined, then they define a unique direction. Then we have to discuss x-intercept, y-intercept. See this diagram. In this diagram, we draw this line, and this line intersect x-axis, intersect y-axis. Where this line intersect, called the intercept of that line. When that line intercept on x-axis, that is x-intercept. When that line intercept on y-axis, that is y-intercept. We know that on x-axis y coordinate is 0, on y-axis x coordinate is 0. So we write here coordinate of point on x-axis as a0. That means this point at a distance small a from origin, and this point its coordinate is 0b. So this point has a distance small b from this origin. So we see x-intercept. The x coordinate of a point at which a line intersects x-axis is called the x-intercept of that line. That is, if a line intersects the x-axis at the point A of A0, then A is called the x-intercept of the line. Y-intercept, the y coordinate of a point at which a line intersects y-axis is called the y-intercept of that line. That is, if a line intersects the y-axis at the point B of 0P, then B is called y-intercept of the line. Now next topic is inclination of a line. We know that when a line make angle theta with positive direction of x-axis, in this diagram we consider here theta, this line we draw here, and this line makes angle theta here with positive direction of x-axis, then this theta is called inclination of that line. So see the point. The measure of an angle made by a line in an anti-clockwise sense, that is direction, that is with the positive direction of x-axis, is called an inclination of the line. Means when line makes some angles with positive direction of x-axis and that inclination must be anti-clockwise, that is the direction must be anti-clockwise, then the angle measure is called the inclination of a line. The inclination of x-axis or a line parallel to x-axis is 0. That means if we see the inclination of this x-axis, then its inclination with itself is 0. And if we consider a line, here we consider line capital L, which is parallel to this x-axis, then inclination of this line L, which is parallel to x-axis, is also 0. Next point, the inclination of the y-axis or a line parallel to the y-axis is 90 degree. That means if line is parallel to y-axis or inclination of y-axis is always 90 degree. Because this y-axis is perpendicular to x-axis, that means a line parallel to y-axis is always perpendicular to x-axis. So the inclination of y-axis or line parallel to y-axis is always 90 degree. Next point, the inclination of the line bisecting the angles of the first and third quadrant is 45 degree. Here we consider line M, which bisect the quadrant first and quadrant third. When a line bisect first and third quadrant, then we have to take its inclination, that is 45 degree. In same way, if we consider a line capital L which bisect second and fourth quadrant, then we have to take its inclination 135 degree. So see the last point, the inclination of the line bisecting the angles of the second and the fourth quadrant is 135 degree. Then we come to the point, slope of a line. If a line makes an angle theta with the positive direction of x-axis and theta must not equals to pi by 2, then the slope of the line is m equals to tan theta. Why we have given here a condition theta equals to pi by 2? Because theta not equals to pi by 2. If we consider theta equals to pi by 2, and from this formula if we substitute the value of theta by pi by 2, that means m equals to tan pi by 2, that is tan 90, and we know that tan 90 is not defined. So when the angle is 90 degree, we cannot define its slope. This is formula for calculating the slope of a line. Second, slope of x-axis or any line parallel to x-axis is always 0. That means when we calculate the slope of x-axis, we know that inclination of x-axis with itself is 0, or a line parallel to x-axis. Here we consider line P which is parallel to x-axis, so its inclination is 0. So tan 0 is 0. So by using the formula we can say that m equals to tan 0 equals to 0. That means slope of x-axis or line parallel to x-axis is always 0. Therefore slope is always 0. Now third point, slope of y-axis or any line parallel to y-axis does not exist. Here we consider line P. This line P is parallel to this y-axis, and we know that this y-axis is always perpendicular with x-axis, so the inclination is 90 degree, and after calculating the value of tan 90 we get infinity. That means a line parallel to y-axis has slope not defined. Therefore slope is imaginary or does not exist. Now the point 4, slope of a line ax plus by plus c equals to 0 is when equation of line is given in general form, then we calculate the slope of that line by using the formula m is equals to minus x coefficient upon y coefficient. That we can write here, the coefficient of x upon coefficient of y. That will be the slope of that line. Then next, slope of a line passing through points x, y and x1, y1 and x2, y2 is. Now here we consider a line and 2 points x1, y1, x2, y2. On any line we consider any point xy. So here we know that on line there are more than 2 points on that line. So we consider any point as xy and 2 points other than xy are x1, y1 and x2, y2. So by using the slope, we know the formula for slope y2 minus y1 upon x2 minus x1, or you can write y1 minus y2 upon x1 minus x2, provided that x1 not equals to x2, because when denominator is 0, we know that any number upon 0 that is not defined. Next, conditions for parallel and perpendicular lines. We know that when two lines are parallel, then their slopes are equal. When two lines are perpendicular, then their slopes product is -1. Suppose line P and Q has slope m1 and m2. Then if these two lines are parallel, then their slopes must be equal. When their slopes are equal, then that lines are parallel. So for conditions we write here, lines are parallel if and only if m1 equals to m2. Lines are perpendicular if and only if m1 into m2 equals to -1. That means when we have to find slope of a line, if any one of line slope is given and condition is given whether the lines are parallel or perpendicular, so using that condition we can find the slope of remaining line. So in note you have to note down parallel lines when m1 equals to m2, perpendicular lines when m1 into m2 equals to -1. So when lines are perpendicular, we can write this as m1 equals to -1 upon m2 and m2 equals to -1 upon m1. One slope is a negative reciprocal of the other slope. Then next, distance formula. The distance of a point P of xy from the given origin O of 0 0 is given by, we know the distance formula, so we see this second point first, then we come to this first point. The distance between the 2 points A of x1 y1 and B of x2 y2 is given by, this is distance formula, or you can write here length of AB or distance of AB. If point A and B are given, its coordinates are given, so we use this formula x2 minus x1 its bracket square plus y2 minus y1 its bracket square. So if we have given any one of its point is origin, so here we can replace this x1 y1 by 0 0 or x2 y2 by 0 0 and other point by xy coordinate. So we write here distance of a point P of xy from the origin of 0 0 is given by distance of OP equals to x square plus y square. Then next is midpoint formula. Next is section formulas. In that first point is midpoint formula. Here we are given 2 points, capital A and capital B. Coordinate of A is x1 y1, coordinate of point B is x2 y2, and coordinate of midpoint is P of xy. Then we can write this coordinate xy in terms of x1 y1. So see the first midpoint formula. If P of x1 y1 is the midpoint of segment AB, where A stands for x1 y1 and B stands for x2 y2, then coordinate of point P are P of xy equals to x1 plus x2 upon 2, y coordinate is y1 plus y2 upon 2. This is midpoint formula. Next, section formula. There are two section formulas, section formula for internal division and section formula for external division. If the point divides segment AB internally, then that is called section formula for internal division. If the point divide externally, that is, if the point right to the sec AB or left to the sec AB, then that is external division. So we first see internal division. If the point P of xy divides the line segment AB internally in the ratio m is to n, where A of x1 y1 and B of x2 y2, then the coordinates of point P are P of xy is equals to. Now see here how to write the x coordinate. While writing the x coordinate, if the ratio is m is to n, so see here we write m into x2 plus n into x1 upon m plus n. So we write here mx2 plus nx1 upon m plus n. When we write y coordinate, then we have to write y is equals to m into y2 plus n into y1 upon m plus n. This is section formula for internal division. When this point P, we shown in third diagram, when this point P of xy divide this sec AB externally in the ratio m is to n, then we have to write in place of plus sign here minus sign. So if the point P of xy divides the line segment AB externally in the ratio m is to n, where A of x1 y1 and B of x2 y2, then the coordinate of point P are, first x coordinate is mx2 minus nx1 upon m minus n, y coordinate is my2 minus ny1 upon m minus n. And the proof for this section formula for internal division and external division, which we also see in vector chapter also. Now the next point is centroid formula. If vertices of triangle is given and we know that centroid is a point which is equidistant from the vertices. So if vertex A has coordinate x1, y1, vertex B has coordinate x2, y2 and vertex C has coordinate x3, y3, then this centroid G, its coordinates are xy and which is given by the formula x is equals to x1 plus x2 plus x3 upon 3 and y coordinate given by y1 plus y2 plus y3 upon 3. This formula is called centroid formula. Then we have to must know some standard equation of lines. So the first is equation of line. In that equation of x-axis, we know that on x-axis y coordinate is 0. So from that we always remember equation of x-axis is y equals to 0. Similarly, equation of y-axis is x equals to 0. Then equation of a line parallel to x-axis is y equals to b. When we have to find equation of line parallel to x-axis, that line has some distance from that x-axis, that line has a distance which is y coordinate. So we write here equation of line parallel to x-axis is y equals to b. Similarly, equation of line parallel to y-axis is x equals to a, where a is x-intercept and in this first b is the y-intercept. Then slope point form. The name itself indicates that the equation of line must contain a point and a slope of that line. See this diagram. In this diagram, we consider a point a of x1, y1 and any point on that line, that is p of xy, and if the line of this slope is m, then its equation is given by y minus y1 equals to m in bracket x minus x1. This we can derive from the slope of a line. If 2 points are given, we know the formula. Slope m equals to y2 minus y1 upon x2 minus x1. Here instead of x2, y2, point coordinate is xy. So you can replace and rearranging we get the equation. So the slope point form, equation of a line passing through the point p of x1, y1, passing through the point x1, y1 and having slope m is y minus y1 equals to m in bracket x minus x1. This is most important form because we use this in application of derivative while calculating the equation of tangent and equation of normals. Then 2-point form. So the name itself suggests that line contains 2 points. Equation of a line passing through the point x1, y1 and x2, y2 is. So here we consider this first diagram. On that we consider 2 points, capital A, capital B. Coordinate of point A is x1, y1, coordinate of point B is x2, y2. So if we calculate the slope of AB, slope of AP, slope of BP, then that all the points lie on a same line, then their slopes are equal. From that we write y minus y1 upon x minus x1 is equals to y1 minus y2 upon x1 minus x2. This is a 2-point form. Then next is slope intercept form. So if slope is given and here intercept must be y-intercept. If in the problem intercept is not mentioned, then we have to consider that intercept must be y-intercept. equation of a line having slope m and y-intercept as c is y equals to mx plus c. This is slope-intercept form. Slope is m, y-intercept is small c. You can see this second diagram. Here line passing through this point b of 0c. So the y-intercept is small c here. And slope of this line is given, that is we consider here m. So the slope intercept form is y equals to mx plus c. Slope origin form. Equation of a line passing through the origin and having slope m is y equals to mx plus c. When this line passes through the origin, then this slope m equals to, or we can say here intercept is 0. So we write here y equals to mx. So in place of c we have to write c equals to 0, that is y equals to mx is the equation of line passing through the origin. Then double intercept form. When a line intercept to both axes, x-axis and y-axis, suppose here this line AB intercept on x-axis at point A, its coordinates are A0, intercept on y-axis at B of 0B. So its double intercept form is x by A plus y by B equals to 1. So equation of a line making non-zero intercept A and B on x and y axis respectively is x by A plus y by B equals to 1. Next form is inclination of a line, inclination form or normal form. Generally we call it normal form. The equation of a line such that the perpendicular drawn from the origin to the line has length p and inclination alpha is x cos alpha plus y sin alpha equals to p. Here line is given. If we draw a perpendicular, so from origin we draw a perpendicular, so here perpendicular is ON. If length of ON is small p and inclination of this perpendicular with x-axis is alpha, then we write normal form as x cos alpha plus y sin alpha equals to p, which we already proved in class 11 how to find the equation of line in normal form. Next is point origin form. Equation of a line in point origin form is x upon x1 is equals to y upon y1. Then mostly used form is general form. The general equation of a line is ax plus by plus c equals to 0, where its slope, when we have to find the slope of a line from general form, we have to remember m is equals to minus a by b, that is coefficient of x upon coefficient of y. Then x-intercept is minus c by a, y-intercept is minus c by b. Hence, lines ax plus by plus c equals to 0 and ax plus by plus k equals to 0 are always parallel for all c and k. If you observe these two equations, the terms of x and y and its coefficients are same, only the constant is different, then that line must be parallel. The lines ax plus by plus c equals to 0 and bx minus ay plus k equals to 0 are always perpendicular for all c and k. If you observe these two equations, coefficient of b is coefficient of x here, coefficient of x is coefficient of y here, and sign is opposite here. Sign of x coefficient is minus here. So from this we can identify these two equations are the equations of line which are perpendicular. Then next is parametric form. This form we also discuss in complex number chapter, that is parametric equation of circle. The parametric equations of a line are x is equals to x1 plus r cos theta and y is equals to y1 plus r sin theta. There we remember that x equals to r cos theta and y equals to r sin theta are the parametric forms. Next we have to see acute angle between two lines. When we have given slope of two lines, suppose first line slope is m1, second line slope is m2, and acute angle between them is theta, then by using this formula tan theta is equals to mod of m1 minus m2 upon 1 plus m1 into m2, we can find the acute angle between that two lines. If m1 and m2 are the slopes of the two lines, then the acute angle theta between the lines is given by tan theta equals to m1 minus m2 upon 1 plus m1 into m2. Here m1 into m2 not equals to minus 1, because m1 into m2 equals to minus 1, that means that lines are perpendicular. When lines are perpendicular, then tan theta, that is tan 90 is not defined. So if m1 equals to m2, then the lines are parallel. If m1 into m2 equals to minus 1, then the lines are perpendicular. Then next point is perpendicular distance. When we have to find distance of a point to the line, then that distance must be perpendicular distance. So see this diagram. We have given equation of line ax plus by plus c equals to 0, and we have to find the distance of this line from this point, and point is p of x1 y1. Then we use this formula. We have to replace this x and y by x1 y1. So see the formula. The perpendicular distance between a point x1 y1 and a line ax plus by plus c equals to 0 is given by mod of ax1 plus by1 plus c upon under root a square plus b square. In denominator we are writing the coefficients of x and y and its square sum. Then second point, the perpendicular distance between a line ax plus by plus c equals to 0 and the origin is given by, here we consider any coordinate, that is x1 y1. If we have to find the distance of a line from the origin, then the coordinate of origin is 0 0, so we have to replace in this formula x1 0 y1 0. Therefore these first two terms get 0, we get only c upon under root a square plus b square. Then next, the perpendicular distance between two parallel lines. First line is ax plus by plus c1 equals to 0, and second line is ax plus by plus c2 equals to 0. We already discussed how to identify whether the given lines are parallel or not. When xy terms are same and their coefficients are same, then that lines are parallel. So while calculating the distance between two parallel lines, we have to use this formula, mod of c1 minus c2 upon under root a square plus b square. Then next topic is family of lines. A set of lines which have a common property is called a family of lines. Consider the set of all lines passing through the origin. Here see this diagram. All these lines pass through the origin, but their equations are different. but they have one common property, that all the lines pass through the origin. Equation of each of these lines is of the form y equals to mx. This set of lines is a family of lines. Different values of m use different lines. That means when we substitute value of m equals to 1, we get y equals to x. When we substitute m equals to 2, we get y equals to 2x. That means all the lines pass through the origin, but their equations are different. So the last point, family of lines. How to calculate family of lines? When we have given any two equations, suppose equation of first line is u equals to a1x plus b1y plus c1 and v equals to a2x plus b2y plus c2. Then the equation of line passing through this intersection of when we have to find equation of line passing through intersection of these two lines, then we have to consider this form u plus kv equals to 0. This is for family of line.